We use a lot of municipal compost in this Red Gardens project, as we just can't produce enough compost of our own to be able to satisfy the needs of all the spaces that we grow in. And while it is very convenient to be able to buy in large bags and even truckloads of this clean source of organic matter, I found that it is not very nutritious or very fertile. So last year we conducted a big experiment where we filled a lot of large grow bags with this municipal compost, amended it in different ways to try to improve its quality, and then grew potato plants in it. Overall, I was really disappointed with the results of this experiment, as most of the potato plants produced very low yield, though some did produce considerably more. And I suspect that this compost just has not had a chance to mature enough to be able to release enough nitrogen and other nutrients for the growing plants. So we decided to repeat the experiment again this year to see if this same batch of compost would improve with age. And even before harvesting any of the plants, it's obvious that it hasn't improved enough to grow a good crop of potatoes, at least without additional amendments. The purpose of this experiment is not to figure out the best way to grow a large crop of potatoes in grow bags like this, but rather to use potato plants to see how different amendments can improve the compost that we are using. And the main issue is probably a lack of nitrogen, or there's probably a lot of nitrogen in this compost, but because it was made with a lot of woody material, any available nitrogen is likely still locked up in the compost itself, that the carbon to nitrogen ratio is still too high. And in order for this compost to be a lot more useful for growing vegetables, we would either need to add a lot more nitrogen and perhaps other nutrients, or to allow this compost to mature a lot longer. The batch of compost that we used in this experiment was originally delivered more than 2 years ago and spent the first year underneath a tarp where it had dried out a bit, and then another year in grow bags growing the potato plants and then other crops before overwintering into this year. I expect that this compost would have matured quite a bit more by now, though it did dry out a few times during the growing season last year, which would have interrupted the decomposition process, and perhaps it just wasn't biologically diverse or active enough to begin with, which is something that I wanted to address at the beginning of this season. There was obviously some decomposition as the volume of the compost in each of the bags shrunk. Some of this would have been compaction, but a lot of it was a continual decomposition of the organic matter or the carbon sources within the compost, releasing CO2 gas into the atmosphere and hopefully making nutrients available to the potato plants. So the first task of this season was to consolidate the bags, to use the compost in one bag to top up the other 5 bags of the same amendment type. While doing this, I came across quite a few worms, which was a good sign that there was some life and some decomposition within the compost. So we started this season with 9 sets of 5 bags, each one filled with compost that had been amended in different ways last year and repeating the same amendments this year. In 3 of the sets of bags, we didn't add any additional nitrogen, including a control with just the compost itself. In another set, we added some more rock dust to boost the amounts of trace elements within the compost. And to another set, we added a mix of soft rock phosphate, gypsum, and seaweed meal in order to boost the amounts of phosphorus, sulfur, calcium, and trace elements, which we figured were missing in the compost. To another 3 sets of bags, we added a source of fertility that contained a fair amount of nitrogen, including 1 bag that was amended again with chicken manure pellets. Another bag that had a fair amount of complete organic fertilizer, or COF, mixed into it, which is a general purpose fertilizer that I use that contains a wide range of different plant nutrients. And to another set of bags, I added a conventional soluble fertilizer to boost the amount of nitrogen, phosphorus, and potassium. With the remaining 3 sets of bags, we didn't add any additional fertility at the beginning of the season, instead relying on regular feeding as the plants were growing. We liquid fed 1 set of plants every few weeks with a form of organic fertilizer that I buy in, sprayed the leaves of another set of plants with the same fertilizer as a form of foliar feeding, and we regularly water the remaining set with dilute urine in order to boost the amount of nitrogen that would be available to the growing potato plants. I decided to expand the experiment a bit this year to fill some of the empty grow bags with a fresh supply of compost we had just had delivered, and amended it in 3 different ways several weeks before planting the potatoes. I prepared a slurry of a range of different types of biologically active compost that we had in order to amend or inoculate this municipal compost with a diversity of biology. In another batch of this fresh municipal compost, I added a lot of urine in order to boost the amount of nitrogen. And we mixed in a lot of amendments, including nitrogen, into another batch in order to really boost the fertility of this growing medium. So that gave us 12 sets of 5 bags each, filled with the same type of municipal compost that had been amended in 12 different ways. We set out all 60 bags in a long double row over ground cover fabric, but before planting the potatoes, I wanted to make sure that there was enough biology in each of the bags. So I mixed some of our own biologically active compost, some decomposed wood chip, and some leaf litter in with a lot of water to create a compost slurry that we watered each of the bags in order to inoculate them with this biology. Then we planted 2 seed potatoes into each of the bags at the beginning of April, though I was obviously distracted that day because I failed to plant potatoes into 2 of the grow bags. We used an early variety of potatoes called Vita Bella, which we had grown in these same bags last year and have used in some of the other gardens, so we're fairly familiar with how it grows and would have something that we can directly compare to last year. We then set up a dripper system to make watering all of these bags a lot easier and to ensure that the compost didn't dry out during the growing season. The purpose of this experiment was to try a number of different ways to see how this low-grade municipal compost can be improved. But of course I also wanted to grow a lot of potatoes. I was hoping that enough time had passed, allowing this compost to mature enough, and we had added enough of all the different types of amendments so that the potato plants in all of the different bags would be able to grow really well. But this was not the case, as even by the beginning of June, there was obvious differences in the color of the leaves between the different sets. The darker green leaves indicated that some of the plants were able to get enough nitrogen, and the paler or more yellow leaves indicated that there probably wasn't enough nitrogen to keep these potato plants happy. By mid-June, there was some significant nutrient deficiencies visible in some of the plants, and by the end of June, some of the plants were already starting to die back, but others were still growing really strong with very vibrant leaves. The plants that are growing in the bags that we didn't add any additional nitrogen to are all starting to die back, including the control and the bag that we added rock dust to, though there is some variability. The soft rock phosphate, gypsum, and seaweed meal that we added to other bags seems to be allowing the plants to grow a little bit better, but they are still dying back. The plants that we had been foliar feeding are also dying back, and I still haven't been able to figure out how to get this foliar feeding to work. Perhaps I need to be spraying a lot more frequently. The plants growing in compost that we had added additional nitrogen to at the beginning of the season are doing a bit better on average, but not great compared to some of the other plants. And it seems that some of the nitrogen we added had been absorbed into the decomposition process and locked up into the compost itself, which seemed to have been the same thing that happened last year. The bags that had been amended with conventional soluble fertilizer at the beginning of the season helped the plants grow a lot better, and we added additional supply to boost the fertility at the beginning of June, which seems to be allowing the plants to grow much longer than a lot of the others. And the plants that were regularly liquid fed with either the organic fertilizer that I buy in or with the dilute urine all did better and are still growing strong. We noticed something really interesting with the 3 sets of bags that were filled with the new compost at the beginning of the year. As the potato plants seemed to have been delayed, that they didn't start to appear until well after all the other bags, even though they were planted at the same time. I noticed something similar in the bags that we started last year and in another trial, and it seems that there's something in the new compost that is delaying growth, but I don't know what it is. But now all of the plants in this new compost are growing really strongly, even in the bags that didn't have any additional nitrogen added. Because they had a later start, I wouldn't be surprised if they did grow for longer, and it will be really interesting to see how they continue to develop and how many potatoes they actually end up producing. Even before we harvest any of the potatoes from any of these grow bags, I've already learned a lot from this experiment. It seems that the municipal compost that we use just can't release enough nitrogen or release it fast enough to sustain the growth of potato plants, even though it has had all this time to mature. This, of course, is a controlled experiment with the plants only growing in the compost plus whatever amendments we added. And if we had added the same compost to the soil of the gardens, different processes might take place. But I can't expect this municipal compost to adequately feed the plants in the gardens. And this is something that I've noticed in a few of the gardens where we have been adding this municipal compost for several years, that it seems to take quite a bit of time before the plants start to really grow well. Even adding a wide range of different nutrients doesn't seem to help that much. And it's only by adding nitrogen, and a lot of it, and ideally at several times during the growing season, that the plants seem to be able to grow well. It is disappointing that even after another year, this compost has not decomposed enough to be really useful by itself, though it is still a good form of carbon and can be used as a mulch in the gardens. But I wonder what would have happened if we had allowed the compost to mature for a full year without growing any plants in it, as the plants would have absorbed any available nitrogen, leaving less for the compost and the decomposition process, which might have allowed it to actually mature a lot faster. We're going to begin to harvest the potato plants soon, and it will be really interesting to see how the yields compare within the different types of amendments used and how they compare to last year's crop. And I'm going to continue with this experiment, planting another crop in these bags for the rest of the season, and possibly even another batch of potatoes in the same compost next year. And hopefully, eventually, the compost might mature enough to actually be really useful without additional amendments, but I don't think I can count on that. But I am tempted to amend all of the bags with an additional supply of nitrogen before planting anything else, as it would be really good to get a much better crop on average, rather than knowing that some of the plants that we plant in some of the bags just aren't going to produce very well.